Hi everyone, this is Young, and today I'm going to show you a speaker recognition system developed in Python and based on the Markov model. This application actually helps you to analyze several given text speeches from different speakers. And then if you feed in another unknown speaker's speech, it will tell you who is the best possible speakers for this new file. So let's hop into the details. Basically, we're using the help of Markov module, which identify not only the frequencies of specific letters or words in a speech file, it also helps you to capture the relationships between different words or letters in sequence. For example, to B is a much more likely word sequence than to A or some other syntax errors. So for a simple example, we have a text digits. The model will help you to generate like strings in the length of k and also the length of k plus 1. So here, length of 2 and length of 3. And listing all different keys. Then have the value, which is the occurrences of each different strings in this text. And then we'll just do a log probability calculation using log I'm divided by n, which is the numbers of occurrences of k plus 1 strings and also k strings. To avoid the risk of thorough division errors, I decided to add some constants into this equation. Now let's take a detailed look at the detailed implementations. Let's start from the implementation of a customized hash table. So here I wrote the hash table using linear probing and rewrite all of these functionalities from init, set item, get item, delete item. And also we have a rehashing functionality to make sure when the table reach a certain size, like reach the low factors, it got refactored again to a bigger size table. And then we have this Markov Python file, which contains the actual Markov model, which helps us to generate the k string and also the k plus 1 strings for the input files, and also calculate the log probability for each model. And we have the actual identification functionalities, which generates the models for both speech 1 and speech 2 inputs, and then obtain the log probability for unknown speech accordingly using both models. And then we get the final result through a comparison of two log probabilities. In the end, we have the driver file, which is the speaker recognition.python, which helps the user to do command line arguments. Here we take in the pass for first speech file, the second speech file, the unknown speech file, and also the ITO data structure we would like to use, either the customized hash table or default dictionary. And then we'll get the output, which is the log probability of speaker A utters the unknown speech, or speaker B utters the speech, and also the final conclusion. Also, I implemented a performance check functionality, which helps the user to have a better idea of what is the efficiency or performance for the speaker recognition system under different key values or multiple rungs using either the customized hash table or the Python default dictionary. So here we have a straightforward table view of the running time for each rung and each k value using pandas, and also have a graphical view of the results using Seaborn. So now let's do a actual demo of this system. So let's open up our terminal window, and in order to run this speech recognition, we need to do Python speech recognition system.py, and then the first input should be the unknown speech from a certain speaker, and also the second speech from a different speaker, And then we have another speech, which is unknown at this point. And we decided to use a k-value of 2 and use the customized hash table for this round. Click enter. We'll have the log probability of both speakers uttering the unknown text. And through comparison, speaker A has a higher probability of uttering such speech. So speaker A is most likely to make the speech. Now, so we could do a quick performance check on this. Let's use the same input files, and also we can do a max k value of 5 and run for 3 times. Click enter again. Okay, this is going to take a while, and we have the final results of the average time running this recognition system using both the hash table and the default dictionary. So apparently now we have a longer time using our customized hash table. And here we have the automatically generated execution graph, which shows the direct comparison of using hash table and dictionary. The reason why the customized hash table took longer is due to have a simple hashing algorithm based on the Honor's rule, but like Python's dictionary actually use a more complex and efficient algorithm that is optimized for reducing collisions and also for the collision resolution. Our customized hash table use a linear probing as its strategy, which can lead to clustering and increased lookup time. But Python's dictionary actually utilize a combination of open addressing and separate chaining, which might provide a better collision resolution and faster lookups. So here's the balance that we need to find. Either like you have like a better control on your data structures, you have your ideal or your customized tailored data structure with a certain rehashing standards or load factors, or you want a more efficiency process with some uncontrolled factors. Okay, that is pretty much everything we have for the speaker recognition system in Python using Markov Model. And I hope you enjoyed this video and have learned a bit from this. Please let me know if you have any better ideas on how to improve this application on the actual implementation for this algorithm. And feel free to leave any comments below and stay tuned for the next video. Thanks again and bye.